Hello, everyone. Today I'll be presenting our paper measuring video QoE from the server side at a global CDN. This work was done in collaboration with my colleagues Juan Bran, Kyriakos Zarifis, and Harkirat Bedi at SCAST. Let's look at a typical overview of how video is delivered on the internet. The player requests a series of segments from the video delivering infrastructure, the CDN, which is delivered, and the player populates the segments in its buffer. As long as the player can fetch the subsequent segment before it runs out of the buffer, the player will not suffer rebuffering. In this example, say segment B3 does not arrive in time, in which case the player will then run out of the amount of video that it can play, and the player will then suffer rebuffering, which is the stalling of the video that you see when you're when you're streaming a video online. Now, where does that delay actually occur? Now, it turns out that can happen anywhere in the video delivery pipeline. So let's look at an overview of that. In a typical workflow, if this is a live stream, then the video is actually produced somewhere in a field or in a live video capture. This video is then delivered to an on-premise or a cloud location where this video is encoded and different chunks of the video are produced. These video segments are then delivered to the CDN infrastructure to be delivered to the client eventually. From the CDN, this video segments will then travel to the ISPs, eventually going to the client's home device, and then finally to the device that the player is actually running on, which is the end user device. So each step can add a potential latency to the whole video delivery flow, and delay at any place can lead to rebuffering. The way video providers monitor where the performance degradations are or how the client is perceiving this performance is by sending this information back to the video providing infrastructure. So in this case, the client player will then send beacons, which is data segments, back to the video providing infrastructure, and it will provide statistics on how the video was perceived by the client. How many rebuffering events did it see, or did the video player even start properly? Now, here's the challenge. In a third-party setting where the video provider might be different than the CDN provider, in examples like the player and the video providing infrastructure is not the one that's actually providing the CDN infrastructure, it's possible that the beacons are not visible to third-party CDNs. So for players where they control both ends of the site, where the player is controlled as well as the video infrastructure is controlled, it's possible that the CDN will get access to the beacon data. But in many cases, for a multi-tenant CDN such as ours, it's possible that this data is not easily accessible. So what are the kind of metrics that the clients actually send back? Most important one that has been previously reported as being a key metric for user engagement is the rebuffering ratio. There are other metrics such as startup delays, the bitrate changes, video playback failure, which are also important in tracking how the client perceives this performance of video. So we set out to answer a question in this paper. In case where the third-party CDN cannot get the video performance data from the client or is not easily accessible, can we measure video QoE from the server side? To answer that question, we take a very simple approach to start with. We understand that the client is already fetching all the video segments from the CDN in the first place. So in theory, we could look at all the video segments that are delivered to a particular client, i.e. one session, and then stitch that back together. In which case, if we do see a gap where the client did not fetch a video segment that it was supposed to, then we count that as a gap in the client request. And usually a gap longer than the amount of video that the player already has will lead to a rebuffering event. Let's look at this with an example. So let's say the video session just starts and the client requests the first segment. In this case, this is the first segment that we've delivered. And let's say in this example that each video segment is of 4 seconds duration. So now from the CDN perspective, the CDN has successfully delivered 4 seconds of video to the client. So it is safe to assume that the client player has 4 seconds of video in it. Now, when the second request arrives, in this case, it's at the 3rd second. We do a simple arithmetic. We know that we have previously delivered 4 seconds of video, right? But the subsequent request came at the 3rd second, which means that the first segment was already consumed for at least 3 seconds. That means that the player still has 1 more second of video to play. Now, Let's say the third request for the third segment comes in at the 13th second. We apply the same arithmetic again. In this case, we had delivered video segment B2 in the second segment, but the player already had 1 second of video in its buffer. So we add the 4 seconds of the current segment to the previous buffer length, which gives us 5 seconds of video. And we look at the time difference between the previous segment and the current one. In this case, this was 13 seconds, and the previous one was at the 3rd second from the start of the tracking of the session, which means that the delta between the second and the third segment was 10 seconds. This means that there were 5 seconds where the player did not, in fact, have any video to play, in which case this session would have suffered a video stall because it didn't have the third segment in time. We count these events as rebuffering events. And it's possible that for 1 or 2 clients that calculations like this might not be very accurate. But when we try to estimate video rebuffering in this way for thousands of sessions, if many clients show rebuffering at the same time, then that's a strong indicator that something has gone wrong. Right? There is delay somewhere in the pipeline where a lot of clients are seeing video stalls at the same time. So that was rebuffering and how we try to estimate rebuffering ratio. But there are other metrics that we should also look at. We have more details in the paper where we talk about the time bucket to look at. For example, should you track the same session for a long period of time, or should you track a lot of sessions in the same time bucket and then move on to the next bucket? There are also other important metrics that CDNs already track that are very important, such as the absolute time that it took to deliver a video segment to the client, the amount of bitrate changes, which may or may not be accurate. Some of our findings indicate that sometimes the bitrate changes are for good, and just tracking the amount of changes might not be very accurate. So it's important to only look at the drop of bitrates. And then finally, how many requests that a client is generating to fetch the video itself. For example, if the session is stable and there are no network changes, then in general, the session performance remains very stable, and the client consistently requests the same amount of segments per unit time. And if that value changes a lot, then that's an indicator that the player is trying to do adaptive bitrate or some other techniques where it's not able to stick to one performance level. We talk about these metrics more in the paper. Well, what we do is we take all of this together along with the estimated rebuffering and then combine them into one QoE score. Now, we do capture all of these metrics separately as well, but the benefit of having one combined score allows to have the simplicity of acting on one metric itself. It also allows us to perform validations. So let's look at that. We perform validation with our server-side estimation, SSQoE, with the client-reported rebuffering data for one of our video customers. Now, in this example, we have 2 weeks of beacon data, the client rebuffering data, versus the server-side implementation that we have. As you can see from the top chart, we do see a very common trend between both of the data sets. However, there are some instantaneous spikes that are more prominent in the client data versus the server-side data. We then go ahead and do signal decomposition to allow us to match trends and only look at what is the long-term trend of the performance in terms of QoE that the client data reports, and is that matched in our server-side implementation as well. We do seasonality decomposition where we can see instantaneous spikes as well. And as you can see in the bottom 3 graphs, we do match the trend that's reported by the client beacons as well. And when we look at the seasonality, which is pretty much the diurnal cycle here, we see that we match those as well. There are, however, some spikes that do appear in client beacons that are not available in the server-side data. The residual signal is usually the very instantaneous spikes, where if you see a huge spike in that in the residual signal, then that indicates an anomaly. We were able to accurately validate large amount of deviations in the residual signal with the server-side QoE data as well. And from our results, we got a very high precision for the server-side data, which means that the server-side score that we are generating for QoE accurately reflects what the client is perceiving from its end. So let's look at a few results that we have from server-side QoE tracking at the CDN. We've had this system in production at the CDN since 2020. So let's look at a big live streaming event that the CDN did, the Superbowl 2020 event. A common challenge with even if you have client-side data available or some other data sets that do report performance of video, that it's not possible to quickly take that data set and map it back to the CDN infrastructure. So in this example, what we're showing is during the event, we had an issue where while we were tracking other metrics and server-side QoE at the same time, we saw that the QoE score for Seattle Pop, which is the red line in the graph here, started an upward trend, and that remained high for a consistent amount of time. Now, because we had the server-side QoE tracking ongoing, we were easily able to pin down immediately that it's not any other pop, it's actually the Seattle Pop that's suffering. And while we did the root cause analysis, we found that it was because the cache servers, the CPUs of the cache servers were hitting their limits. And therefore, the asset delivery time was spiking up. And if you remember, that's one of the metrics that we do track in the QoE score calculation. So this really shows the advantage of running a QoE-based model, but also mapping to the CDN infrastructure, where you can easily take an event that happens that's actually affecting the user perceived performance of video and map it back to the CDN infrastructure, which enables a much quicker root cause analysis. Now let's look at a different granularity here. We are also able to look at server-side QoE in terms of the client parameters, such as the user agent or the operating system that is running on. In this data set, we looked at the performance of different user agents where we tracked the combination of user agent and OS over a period of day. And in this case, we did see that Chrome on Windows 7 was received the highest QoE score. Now remember, we do want higher QoE score indicates bad performance, right? The spikes in the QoE score. So we were able to identify which set of clients are actually suffering the most. Now, I do want to point out that it's not because of a particular version of Chrome or Windows 7. It might very well be that having an older version of Windows or Chrome might just be an artifact that the device itself was old, which means that the CPU or the memory on it was also old. But this indicates the power of having a methodology like this, which looks at the access logs from the CDN and produces a score which we can have at the CDN infrastructure level, but also map it back to the client parameters such as user agents. Finally, I do want to compare the server-side QoE metric with a network metric such as RTT. It is very common for network providers or CDNs to monitor RTT as a performance metric, which is mostly a quality of service metric, but not really a quality of experience metric. In this case, we show RTT profiles for the three big US wireless ISPs. Now, as you can see in this chart, the ISP with the worst RTT profile is not necessarily the worst performer with respect to QoE. In fact, if you look at the wireless ISP 1 and wireless ISP 3, they do have significantly different RTT profiles where wireless ISP 3 performs much worse. But when you look at the performance in terms of QoE, we saw very similar QoE performance. So this again drives back the point and the importance of why we should, or why CDN providers should monitor QoE, because RTT and network metrics do not always accurately reflect how the user is perceiving the performance. And methods like server-side QoE enable us to actually understand how the client is perceiving that performance, and if it is important to address that issue. So to summarize this work, third-party CDNs may or may not have visibility into client-reported data. And even if in case they do have that, it's somewhat harder to map it back to the CDN infrastructure, such as POP level granularity. With the server-side estimation that we've proposed with this paper, it's possible to combine it with other CDN metrics, such as request rate, bitrate drops, and then produce a QoE score. Our validations show that the server-side estimations match the trend reported by the client-side data with a very high precision. Finally, the proposed method can then capture QoE at different granularities as well. As I mentioned previously, because we perform this analysis for POP, it's immediately available which POP is the one that's showing higher QoE scores. At the same time, the QoE analysis that we do can reveal impacts that the client sees that can be caused either by server overload, network issues, or device characteristics such as old operating systems. We've had the system in production at the CDN since 2020 and has been extremely helpful for our SRE teams to debug issues and action on them quicker. The next steps include running machine learning analysis on server-side QoE, and especially when we push out changes to our web server or any other feature updates to the CDN. With that, I will take any questions if you have some. Thank you.